Hello, this is FlippedHarber for Algebra 2. In this video we're going to talk about section 5.3, solving quadratic equations by graphing and factoring. Our objectives for this lesson are to solve quadratic equations by graphing. We want to solve quadratic equations by factoring, and we want to determine a quadratic function from its roots. Our outline for this video: we'll talk about what the difference between a quadratic function versus a quadratic equation is, and we'll talk about the difference between zeros and roots. Now, the difference between a quadratic function and a quadratic equation: if you have f of x equals, that's a function. If you take that quadratic and actually set it equal to a number, preferably equal to 0, that's an equation. So if you see the f of x, it's a function. If you don't see that f of x and it's equal to a number instead, then it's an equation. Simple enough. Now, the difference between zeros and roots. Basically, quadratic functions have zeros. That is where the graph crosses the x-axis. Quadratic equations have roots. So the difference is a 0 is for a quadratic function, or really any function. A root is the solution of a quadratic equation, or any equation really. Pretty much the same thing, just kind of depending on what you're talking about. Now, if we graph a quadratic function and it does not cross the x-axis, then that function has no zeros, and that means that if we set x squared plus 1, in this case, the function equal to 0, it has no roots. No zeros, no roots. This would have 1 0, or if it was an equation, it would have 1 root. This quadratic has 2 zeros because the graph crosses the x-axis in 2 spots. So this quadratic equation would have 2 roots. Now, to find the zeros of a function by factoring, you should be familiar with this, but you might need a little bit of reminding. I need to identify factors of 12 that will add up to 8. Now, I need to also look at my signs. The plus in front of the 12 tells me that my two factors will be the same sign. They'll both be negative, or they will both be positive. The negative in front of the 8 tells me that they're both going to be negative. So the factors of 12 that add up to 8 are 2 and 6. So my two factors are x minus 2 and x minus 6. Now, the reason we factor in order to solve, when we factor it and we have these two factors are equaling 0, we can set each factor equal to 0 separately. So I take x minus 2, set it equal to 0 by itself. I take x minus 6, set it equal to 0 by itself. Now I get my two solutions, x equals 2 or x equals 6. Let's try to factor this one. Now, the difference between this one and the previous one really is the fact that there's no c value. There's no constant at the end. So the way we're going to factor this is we're going to go ahead and pull as many numbers and letters as we can out. So I can factor a 3 out of both 3 and 12. I can also factor an x out because 3x squared has 2 x's in it. 12x has an x, so I'm actually factoring 3x out of both of those terms. I'm left with x plus 4. This is a division process. I could multiply that 3x back in and get my original quadratic. But if we take it factored out like this and set each factor equal to 0 again, so 3x equals 0 or x plus 4 equals 0, I get my two solutions, x equals 0 or x equals negative 4. Now, here's some special cases that you need to be aware of when factoring. A squared minus b squared is what we refer to as a difference of two squares, and you need to know how to factor it basically on sight. Here's an example. x squared minus 9. It's a quadratic because of the x squared. It doesn't have an x term, and the number is being subtracted, and it's a perfect square. So I can factor it to be x plus 3 times x minus 3. Here's two more special cases. The perfect square trinomials. Ax squared minus 2a, I keep on saying that wrong, a squared minus 2ab plus b squared and a squared plus 2ab plus b squared are two perfect square trinomials. Now they look kind of goofy. How am I going to recognize this when we're in the real world? Well, here's an example. Look at that last number. Is it a perfect square? Yeah, 9 is 3 squared. Look at the middle number. Is the middle number 2 times 3? Yes. So this is a perfect square trinomial. This is actually an example of the bottom one. So I can factor it to be x plus 3 squared. Let's take a look at some examples now. I want to solve this quadratic equation. The first thing I need to do is get everything on the same side and set it equal to 0. Now I'm going to factor out as big of a number as I can. What's the biggest number that I can factor out of 8, 56, and 98? Well, I can actually factor out a 2 from everything. Now I need to factor the trinomial. So it's going to factor into 2x minus 7 times 2x minus 7. So it didn't exactly look like it at the beginning, but it was actually a perfect square trinomial. Now I only need one of these 2x minus 7s. I don't need to set them both equal to 0. I'm just going to set one of them equal to 0, and I'll solve for x. And I get x equals 7 halves. What about this one? 4x squared equals 36. Well, there's no b term, there's no x value, so I'm just going to go ahead, leave them separated like this, divide the 4 over, and now I take the square root. I get x equals plus or minus 3. Now, if we want to write a quadratic equation in standard form with some given roots, this is basically the opposite of what we've just been doing. We've been trying to factor out these quadratics in order to solve them. Now we're going to do the exact opposite. We're going to create two binomials and multiply them together to get a quadratic. Our two binomials come from x equals 4 and x equals negative 2. We move the 4 over, we get x minus 4. We move the negative 2 over, we get x plus 2. Here are the two binomials. That's what we multiply together in order to get our quadratic. So our quadratic is x squared minus 2x minus 8. Okay, so now it's time for you to get started on that homework. I'll see you in class, and I'll see you online.